This video is for Chapter 13, Section G, which is the relationship between lines, or relationships between lines. So, in 2 dimensions, lines can be parallel, intersecting, or coincident. And then the perpendicular would fall underneath intersecting. In 3D, they can be also parallel, coincident, intersecting, or they can be skew as well. So, if they're skew, they're non-coplanar and they're non-intersecting. So since they're non-coplanar, they can't be parallel either. Now, they don't intersect, but if we want to talk about the angle between 2 skew lines, even though they don't intersect, we can do that. Just think about translating one of them so that it does intersect with the other one, and then the angle between the translated lines will be considered the angle between the skew lines. Okay, so now example 14. Line 1, x equals, negative 1 plus 2s, y equals 1 minus 2s, z equals 1 plus 4s. Line 2, x equals 1 minus t, lost my place, y equals t, and z equals 3 minus 2t. And it says show the lines are parallel but not coincident. 1 parallel to but not coincident. So we need to show 2 things. So in order to show that they're parallel, let's do that first. And we've talked about that already. We just need to show their direction vectors are scalar multiples of each other. So I'll call B1 the direction vector of line 1, and we get that. So that's going to be 2, negative 2, 4. And then vector B2 will be the direction vector for the other line. And we can look at it. We can take the x components. What would you multiply? Actually, I'm going to do B2 because it'll be easier, I think. I could take B2 and multiply it by negative 2. And if I did that, I would get the x coordinate for B1. So let's check and see if that works for all of them. So let's take this vector, B2, and multiply it by negative 2 and see what we get. So we'll get 2, negative 2, 4. And then we can check and look and see that that's identical to the direction vector for B1. So that proves that B1, vector B1, is a scalar multiple of vector B2. So the part that I've put in the box here proves that, and then you could say therefore L1 is parallel to L2. I'm just going to check in the book and see, yeah, that's pretty much what they did there too. Then, but we also have to check and make sure they're not coincident, because they could be. So what you can do to figure that out is you could make up a value for s and see what you get for a point. And the book was very clever because they noticed that y equals t. Well, so this is what they did. They chose s equals 0 because that was easy. So when s is 0, I think I'll go to a different color, orange. When s is 0, L1 will be, it'll correspond with the point, -1, 1, 1. And then, fortunately, we have y equals t, so we know that 1 is the y, so that means that t is equal to 1. And then you can now plug in 1 for L2 and get the corresponding point on line 2. So if I'm plugging in 1 for t, I'm going to have 1 minus 1 is 0, I'm going to have 1 there, and I'm going to have 3 minus 2, which is 1. And you can see that when s is 0, t equals 1, and you will not be at the same point on each line. So they're not coincident, because -1, 1, 1 does not equal 0, 1, 1. Next is example 15. And of course it did not switch colors because it never does. So let's go again. I like purple. Okay. Example 15, we have 3 lines. We're given in parametric form. I'm about to sneeze. Okay, L1. L2. And L3. Letter A, this has 2 parts. Show line 2 and line 3 intersect, and find the angle between them. Okay, so to show that they intersect, that means that they meet at a point. So, okay, L2 and L3. So what we can do is we could set the x's equal to each other. So if they're going to intersect, then they equal each other. So we're going to do 1 minus t equals 1 plus 2u. So I'm setting the x's together. But that's two unknowns, so I need another equation. So let's do y equals t. Oh, that's very handy. Actually, we know y equals t. Oh, what the heck, I'll just do it. So we're going to set the y's equal together. T equals -1 minus u. You could have also just substituted in, well, yeah, that works. Let's just do that. So t equals -1 minus u. Now we have 2 equations, 2 unknowns, and we can solve. I'm going to use substitution because I've got t solved. So I'm going to plug in, I'm going to do 1 minus, I'm replacing t with -1 minus u. Now they're all in terms of u, and we can solve. So that's going to be +1 plus u equals 1 plus 2u. 1 plus 1 is 2. Let's subtract u. Let's subtract 1, and we get u equals 1. So then that means t, we can go back up here, plug in 1 for u. That's going to be -2. And then we can find. Now what we can do, because we have, just kind of looking here, we have everything we need, we can show that L2 will be, so I'm going to plug in 1 and I'm going to plug in the u and the t. So I've got 1, for x I've got 1 minus t, so that's 1 minus -2, which is 1 plus 2, so that's 3. And then y is t, and z is 3 minus 2 times -2, so that's going to be 3 plus 4, which is 7. Now let's do L3. X is 1 plus 2 times u, so that's going to be 1 plus 2, which is 3. Y is -1 minus u, so -1 minus 1 is -2. And then I'm going to have 4 plus 3 times 1, so that's 7. All right, that's good news. So that means they do intersect, and we have shown that they intersect at this point. So you could say, therefore, L2 and L3 intersect at the point 3, -2, 7. Then it wants us to find the angle between them. So if we think back to our cosine formula, it's going to be the absolute value of their direction vectors dotted together, the dot product. Oh, I better just keep it, it's L2, so B2 and B3. And then the magnitude of vector B2 and the magnitude of vector B3. So we'll go ahead and do that. I'm going to do a little bit of erasing over here. And feel free to do this on your own. Pause the video and then come back, and I'll be doing the work over here. Cosine theta equals, so direction vector for B2 is -1, 1, -2, dotted with the direction vector for B3, which is 2, -1, 3, all over the magnitude of B2, the direction vector, which would be -1 squared plus 1 squared plus -2 squared, times the direction vector magnitude of the other one, 2 squared plus -1 squared plus 3 squared. And then we just do the math. So I'm going to have -2 minus 1 minus 6, the square root of 1 plus 1, so 2 plus 4. And then 4 plus 1, which is 5, plus 9, which is 14. Making sure I don't make any mistakes. Okay. So that's going to be what? 6, 7, 8, 9. So 9, because it's absolute value, over, let's see, what's 14 times 6? 84. That's going to equal cosine theta. So then you do the inverse cosine, and I will look at my notes, because I already did this problem, and see what we get for an answer. Oh, where is it? I got 10.9 degrees. Great. So that problem, or A is done. That was just letter A, believe it or not. So now letter B asks, show that line 1 and line 3 are skew. So I'm going to erase. I don't want to have to rewrite all the equations, so I'm just going to erase the bottom part here. So if they're skew, they're non-coplanar. That means they're not parallel, and they don't intersect. Sorry about that. Letter B, let's go to a new color to make it interesting. We'll do red. Okay. Show L1 and L3 are skew. So in order to do that, we have to show they don't intersect, for one thing, and that they are not parallel. So, okay, we'll show they don't intersect. Oops, don't. So I'm going to do the same thing I did on the other problem. I'm going to make the x components equal, the y components equal, and so on. And we should see. Let's see what happens when we try that. So L1 and L3, those are the ones on the top. Okay, so we've got the x is -1 plus 2s equals 1 plus 2u. And the y is y minus 2s equals -1 minus u. Two equations, two unknowns. I am going to, I could go ahead and add these the way they are, because I've got 2s and -2s. I don't even really have to simplify it. Let's just do it. So I'm going to add them. This is going to go to 0, that's going to go to 0, that's going to go to 0, and I'm going to get u over here. Okay, u equals 0. So we could plug that back in. Negative 1 plus 2s. I'm bringing back what I had here. 2 times u, which is 0. So I get 2s equals 2, s equals 1. And now what we're going to do is check this in the z's. So z is 3 minus 2 times t. Oh, I'm on the wrong one. No wonder that didn't make sense. Never mind that. We're not working with L2 on this problem. Let's cross that out. Okay, L1. So I'm plugging in, I want to find z. Z equals 1 plus 4 times s, which is 1, so z equals 5. And then L2, z equals 4 plus 3 times u, which was 0, so z equals 4. And this confirms that they don't share the same z-coordinate, so they cannot intersect. So you could say 5 doesn't equal 4, therefore L1 does not intersect with L2. Or, yeah. Okay, so like I said before, if we have to show they don't intersect, but we also have to show that they're not parallel, because if they were parallel, then they wouldn't be skew. So we could probably do that right here. Let's see if we can do that. Now we need to go to black. Part B, kind of. Show L1 and L3 are not parallel. And we can look at their direction vectors. So for L1, the direction vector is 2, negative 2, 4. And then for L2, the direction vector is 2, negative 1, 3. And so right away, if I was looking at the x-coordinates, I would see they both have a 2. So that means if they were parallel, the scalar multiple would have to be 1. But then if you look down on the y's, if you multiplied negative 2 by 1, you would not get, you know, it's not a scalar multiple because it's negative 1 instead of negative 2. So you could say B1 and B2 are not scalar multiples of each other. Therefore, L1 and L2 are not parallel. And then you could even, if you wanted to be even more clear about this, the very final thing you should say is that L1 and L3 don't intersect and aren't parallel. Therefore, they are skew.